Welcome to the fifth video of System Programming and Compiler Construction. From this video, I will be starting with the fifth module of the syllabus. This module talks about compilers, and in this module we'll understand how compilers function when it is in its analysis phase. So we'll see the fifth module, that is compilers analysis phase. The topics that I will be covering in my upcoming videos are the introduction to compilers, phases of compilers, then we'll understand what is lexical analysis all about, then we'll see syntax analysis, then there are types of parsers. So here in this particular section, that is types of parsers, we will be solving numericals on each type mentioned, and then we'll go to semantic analysis and end our videos with syntax directed definitions. Let's begin. Compiler. In my previous video, I have already mentioned that there are two types of compilers. There is one section of compiler who is responsible for converting source code into an intermediate code, which you call it as an assembly code. And there are some other compilers who skips this intermediate step and converts the source code directly into machine code. Hence, now onwards in the upcoming videos of mine, I will be not saying assembly code or machine code. I will be referring the output of compiler as target code. The slide says the compiler is an application that converts the programs into high-level language into lower-level language that the computer can understand and execute. The first compiler was thought to have been designed way back in 1952. Thus, a compiler typically maps a source program into semantically equivalent target program. Semantically equivalent means the meaning of the program should not change while the compilation process is happening. In other words, if the source code is responsible for doing some task, after the target program is generated, the target program should also do the same task. The compiler does this conversion in two phases. The first phase is the analysis phase and the second is the synthesis phase. There are two main phases of compiler. The analysis phase. The analysis phase is considered to be the front end of the compiler and it is said to be language dependent. Why it is known as the front end of the compiler? Because it is this phase which receives the source code written by the programmer. And the analysis phase is responsible for generating an intermediate code, and this intermediate code, since is not attached to any target processor, it is considered to be machine independent, and since it is responsible for receiving the source code, it is said to be language dependent. The second phase is the synthesis phase. Synthesis phase is said to be the back end of the compiler because it is this phase who accepts the intermediate code produced by the analysis phase and converts it into the machine code. Since it is converting it into machine code, it is machine dependent. It depends on what is the underlying architecture, and based on that the machine code is generated. And since it does not directly accept the source code, it is said to be language independent. Now what happens in analysis phase? In analysis phase, the compiler is responsible for breaking up the source code into its constituent pieces, and then it imposes some grammatical structure on them. It then uses this grammatical structure to create an intermediate representation of the source program. So this is just what I said. The analysis phase is responsible for creating an intermediate code from the source program that it has received. It is the analysis phase which is responsible for identifying the errors in the source program. It checks whether the source program is syntactically ill-formed, or it checks and it also checks whether the program is semantically sound. If the program is not syntactically correct, or if it is semantically unsound, then the analysis phase is responsible to show such kind of messages to the user, and the user is then responsible to take some corrective action. The analysis phase also is responsible for collecting information from the source program. This information, which is collected from the source program, is stored in a table which is known as symbol table. This symbol table, along with the intermediate code, is then submitted to the synthesis phase. What happens in synthesis phase? This phase receives the receives the intermediate code, and it receives the symbol table. Based on the intermediate code received from the analysis phase and the symbol table received, the synthesis phase is responsible for constructing the required or the desired target program. Diagrammatically, analysis phase receives the source program. It is responsible for doing two things. It checks whether there is any error. If yes, it halts the execution there itself and asks the user to rectify the errors. If the program is error free, the analysis phase is responsible for constructing intermediate code, also known as intermediate representation and symbol table. These things, that is intermediate representation and symbol table, is then submitted to the synthesis phase. The synthesis phase is responsible for generating machine code. So, these are the steps the compiler has to take when it is converting the source code into target code. The source code, which is written in high-level language, is first submitted to the lexical analyzer, which is also known as scanner. This step is known as lexical analysis step. The output of lexical analyzer is then submitted to syntax analyzer, which is also known as parser. The syntax analyzer is responsible for performing syntax analysis. The output of semantic analysis or semantic analyzer is submitted to, the output of syntax analyzer is submitted to semantic analyzer. Then the next step forms the intermediate code generation. Lexical analysis, syntax analysis, and semantic analysis is responsible, or you can say are responsible, for creating symbol table. Intermediate code generated and symbol table is then submitted to the synthesis phase. The highlighted phase come under the analysis phase of the compiler. Once receiving the intermediate code and symbol table, the synthesis phase does the task of optimizing the code, and the code is optimized using something known as code optimizer. This optimized code is then given to the target code generator, who is responsible for creating the target code, or you can say it is responsible for creating assembly code. The highlighted phases in red are the steps that are carried out in the synthesis phase. If you observe, the synthesis phase is responsible for information that is already stored in the symbol table. This slide will give you the detailed analysis of each step that is carried out by compiler. As marked, the first four steps form the analysis phase of the compiler, and which is also known as the front end of the compiler. The last two steps are the steps carried out in the synthesis phase, and they are known as the back end of the compiler. Let us see what output is generated after each step is completed. Once lexical analysis is completed, the output that is generated is stream of tokens. After syntax analysis, or the syntax analyzer is responsible for generating syntax tree, which is also known as parse tree. Semantic analyzer is responsible for performing type checking, and thus it is responsible for creating a tree which is semantically verified. Intermediate code generation is responsible for generating intermediate code. Code optimization gives me my optimized code, and target code generation will give me my target code or assembly code. Let's see what happens in lexical analysis. Lexical analysis is the first step of the analysis phase. It is the first phase of the compiler in which the source code is scanned. This phase is handled by lexical analyzer, which is also known as scanner. In this phase, the lexical analyzer is responsible for reading the input character by character from left to right, and it groups various characters into tokens. The characters are grouped based on some meaning. In other words, every lexical, or you can say a lexical analyzer, is already having a knowledge on what basis the characters needs to be grouped. This meaningful group of characters is known as lexeme. Let us see what is the definition of lexeme. A lexeme is a sequence of characters of a program that is grouped together as a single unit. When a compiler or interpreter reads the source code of a program, the compiler breaks it down into smaller units called lexemes. So the lexical analyzer already knows how to group those characters. And once it has grouped those characters, each group fall under the category of lexeme, or each group is known as lexeme. For each lexeme, the lexical analyzer produces as output a token which is of the form token name and attribute value. In this phase, there is a symbol table which is created. This symbol table is populated with the tokens generated by the lexical analyzer. What is symbol table? A symbol table is a data structure that holds a record for each identifier in the source code. Thus, the output of this phase is stream of tokens. What are the types of lexemes? Say for example, if this is the input which is given to my lexical analyzer. Suppose I write int x is equal to 10 and then I give semicolon. As soon as this input is read by the lexical analyzer, it will start reading this expression character by character, and then it will start grouping these characters. It will group int as one. It will make a group of int. It will have the next group x, then it will have next group w, next group 10, and the last group will be semicolon. Thus, each group which are highlighted on the slide falls under one of the category of lexemes. What are those? Int falls under the category of keyword. X falls under the category of identifier. Equal to falls under the category of operator. 10 falls under the category of literal, and semicolon falls under the category of punctuation. Thus, there are 5 types of lexemes: operators, identifiers. Identifiers include all the variable name, function name, or method name. Punctuations, keywords, and literals. Literals hold any constants. Suppose if this is the input given to my compiler, the lexical analyzer as again will start grouping the characters based on some specific meaning. Thus, in this case, I have 1, 2, 3, 4, 5, 6 and 7 lexemes. Okay, I have 7 lexemes. Position falls under the category of identifier. Equal to falls under the category of operator. Initial also falls under the category of identifier. Plus falls under the category of operator. Rate falls under the category of identifier. Multiplication falls under the category of operator, and 60 falls under the category of literal. The lexical analyzer, after creating lexemes, is responsible for generating tokens, and the format of the token is token name and attribute value. So this is how tokens are created. These are my lexemes as said, and these are the tokens: position, initial, and rate. These are identifiers, hence they are given a token name, that is ID, and ID. And each ID is given a sequential value of 1, 2 and 3. Let us take one more example. Suppose if there is this expression given to the compiler, A is equal to B divided by 2. Then in this case, I have again first lexeme, second lexeme, third lexeme, this is my fourth, and this is my fifth lexeme. When I convert these lexemes into tokens, I will observe that there are two identifiers and two operators and one literal. Thus, this is how my symbol table is created. That's all for today's video. I hope everybody have understood the phases of compiler and the detailed explanation of lexical analysis. In my next video, I will be covering syntax analysis, semantic analysis, and intermediate code generation. Thank you everyone for your patience listening.